Okay, good morning. Welcome to today's lesson. Whilst we start, I'd like you to get onto compete.with.co.uk. You'll notice that this week's challenge involves drawing a black and white image. I will put the new week's challenge live during this lesson. I wouldn't recommend doing the type race because there's loads of zeros and ones from the video from last week. What I would like you to work on, please, are the challenges down at the bottom. The little turtle that we went through in last week's video is upside down. Can you work out how to flip it? So you'll have to manipulate the y coordinates so that it's all negative, so that it goes the other way up. A little bit of maths transformation for you. Can you draw it in red and white rather than black and white? And can you speed it up by not drawing the white pixels? Those are your challenges whilst I take the register. Right, so let's have a look. First challenge, flip the turtle so it's not upside down. That's going to be something to do with the coordinates up here. The y coordinates are upside down, as in a positive value for y doesn't go down, it goes up instead, which is confusing. So I'm going to just put 0 minus, and then all of that in here, oops, brackets, and it should draw in the right direction. However, it's kind of moved down from where we want. So what about if we put an offset in? If we say 100, is that going to move it up? Yeah, that looks pretty good. I guess I want it to start at the top of the screen, so I'm going to go 200, but that'll be probably off the top of the screen. But that's not terrible. What if we want to move it across to the left? Well, a transformation in maths means that you just shift the x direction across. So we're going to take off a certain amount. So if we do 200 off the x, that's going to be all of this, which we currently have for the x-coordinate, take away 200. It's going to start from the top left. However, I want all of the pixels to be bigger. Well, that's why we used a constant, isn't it? So that we can change it once and it will affect it everywhere. So how about 10 or 20? That's looking better. We could actually do some maths to make the whole thing fill the screen. Let's see. We've got 32 pixels and 200 to the middle, another 200 to the right. That's 400 pixels. So we can go 400 divided by 32. We want each pixel to be about 12.5 actual screen pixels. So I'm not going to bother with 12.5, but I'll make it 12. And then it should more or less fill the screen. So for the next one, we've got an if statement. If it's a 0, it's going to be black. If what's a 0? Well, any of these values. Remember, this is all about practicing two-dimensional data structures. Instead of black and white, I could go for red and white, or green and white, if you really wanted a green and white turtle. Nice. So one more challenge. Can you speed it up by not drawing the white pixels at all? Oh, yeah, easy. Just get rid of these. Will it work? Now, wherever there's a white pixel, we just don't bother drawing it at all. That's what we're after. You need to open up CT33 from half term 6, please. We should be able to race through it today. We're going to learn how to change the colour, which we know already, but also how to change the width of the line when we're drawing with Turtle Graphics. So you can choose to do this in Thonny, or you can choose to use create.with.co.uk. I would recommend that you're using Thonny because that's what you'll use in the exam. Let's have a look. To the right is the result of experimenting with angular brackets turtle dot pen size. You can reproduce it using some nifty maths with a loop counter. Can we? Let's plop that over here. Remember, this is CT33. We need to import turtle. It says use a for loop with a count going from 0 to 4. If it's going from 0 to 4 inclusive, I need my parameter for range to go up to 5. Because remember, it starts at 0 and it stops one before this. Let's just check and see what that does so far, shall we? Let's run it. We'll need to save it. Do not ever save your Python code as turtle, because that will not allow you to import the turtle module. It will break. So I'm going to call it CT33. Here we go. At the moment I've just got 0, 1, 2, 3, 4. What I want to do is set the pen size to the count times 5. t dot pen size count times 5. Well, it's not going to be able to do this yet because it doesn't know what t is. Class chart's positive for you telling me how to resolve this. Yeah, so we need to make a turtle drawing object. I'm going to call it t. We need to go inside the turtle module, create turtle drawing graphics, and not forget to put the brackets at the end. There we go. It looks like it's crashed. You have to press the stop button up here. What else does it say? Do you know what? If there's ever a question paper that gives you stuff like this, you get marks in like question 4, 5, and 6 for putting comments in and white space, even if you don't know any of the code at all. So I'm going to put some comments in and some white space. White space just means blank lines to like split it up into paragraphs. Right, what have I done? Set the pen size to count times 5. Nice. Set the position to the x coordinates and the y coordinates. All right. Yeah, I need to use the goTo function for this. goTo. I need to specify the x and the y. But it says x is 0. So I'm just going to put 0. And y is going to be 50, not x count. I need to multiply, and that's an asterisk. However, this is not going to look right. That's not what we've asked for. Your challenge, I'm not going to do this for you, is to try and make it look like this. So, first problem that we've got is that the line isn't moving forwards. So let's move forwards by 100 pixels. But remember, when you go to, it doesn't teleport. It draws a line from where you are to where you want to get to. Now, sometimes that's really useful, but most of the time it's not. So we have to lift the pen up and put the pen back down again. And that should be perfect. Screenshot your code, pop it into your CT33, and then move on to activity 2, which is where you do the same kind of thing, but in colour. Let's have a look and see how we can do this. It says, add a list of colours named the colours. That sounds like a global variable. The colours. It's a list, so open, close, square brackets. It says initialize it with 5 colour names. So red and orange and yellow. Or you could have hex colour codes if you prefer, like I don't know, just making up some hexadecimal values. 2 digits of hex means 1 byte, as in 8 bits, or a number between 0 and 255. That would be the amount of red, the amount of green, and the amount of blue. I am going to need 1, 2, 3, 4, 5 colours. 1, 2, 3, 4. Let's put a black in there too, but I'm going to do black in hex, as in all of the red turned off, all of the green turned off, and all of the blue turned off. Then, once we've got those colours, it's not automatically going to use them. We have to tell Python to use them. How? Well, just by saying t.color, spelt the American way because it's built into Python, and your challenge is to work out what goes in the brackets here. Yeah, so we need the name of the list. That's the colours, spelt the British way, because we're British and we chose what to call that here. And in here, sorry, I was making assumptions about people's cultural identity there. Sorry about that. And then we need an index. It's not colour, it's count. Why? Because we've used count as an integer. It starts at 0, and it goes up to 1, 2, 3, 4, and it stops just 1 before this value here. This should work. I'd like you to try and get the colours to match as closely as possible the colours on here. See what you can do. So let's have a look at activity 3. It mentions some code that we are not given today, so we should probably have a look on the VLE and see if we can find it, because it is there, and then we'll just make it ourselves anyway, even if we can't find it, because we want a regular do polygon thing, which sounds very achievable. So let's search for half term 6. It should be activities and homework for CT32. We've got code snippets. Is it this one or is it this one? Not entirely sure. What does it say? You should find it in activities for lesson CT32. It draws a regular polygon. Well, let's see. Is it this one? Nope, it's not that one. Is it this one? Nope. All right, well, let's make it ourselves. How about the homeworky one? Do star. No, no good. Oh, so we haven't actually got it. It's not there. Maybe we need it for CT33. Possibly. Don't know. But I'd like to make it anyway. Because it must be possible. Where's Thonny gone? Have I closed it down? That was irritating. Sorry. There we go. So let's start just from import turtle. It says that we want a subprogram called do polygon. And it should tell us, or we should tell it rather, how many sides that we want to draw. So what is a polygon? Well, it's a regular polygon, which means all of the sides are the same shape. So for side in P sides, we want to move forwards, T dot forwards by a certain amount. Well, we probably want to specify how big it is. So P size as well. P size. We want to rotate, either left or right, doesn't really matter, by an angle. Don't know what the angle is yet, so we should probably test it. Right, let's test it with the simplest ones. Polygon. Let's test it with 4 sides, that's a square, 100. So it doesn't know what angle is. Oh, hang on. We can't iterate through a integer. We can iterate through an integer if we pass it as a parameter, sorry, an argument into a function and get a iterable object back or a list object back. Let's try that. Doesn't know what t is. Okay, let's make t. T equals turtle dot turtle. Right, now it's not going to know what angle is. Oh, where's R come from? Yuck. Just misspelt that. And now it doesn't know what angle is. Okay. Well, we can use our maths now. We can work out that the angle is going to be, let's see, 360 degrees in a shape. Divide that by the number of sides that we have. Will it work? Don't know. It works for a square. Will it work for a pentagon? Oh, yeah. Will it work for a triangle? Yeah, nice. I don't know if it'll work for a star. Find the subprogram to draw a 5-pointed star. Ugh. So that sounds like something else that we better draw. So should we specify how big it's going to be? Draw a star with sides of 100 at, so we need to specify the size. Right, how do we draw a 5-pointed star? Yikes. How many lines are there in a 5-pointed star? If we've got 5 points and there's 2 lines at each point, that means there's going to be 10 lines. That's my guess. T dot forwards by P size and T dot right by a certain amount. I've been corrected. There are only 5 sides. Absolutely right. But what's the angle that we turn by each time? Don't know. So 144 in here. Let's not draw a polygon. Let's draw a star with sides of 100. Will it work? Oh, it's looking promising. Yes. Can we draw it bigger? Yeah. It works. Fab. I think you've got everything that you need here to be able to do activity 3. So let's go through the first part here. I've realized we'll need to refactor some of these subprograms because it says create 2 turtles, one called Bob and one called Alice. So we've currently got T at the moment. If we make Bob and Alice, then our code's not going to work anymore because we don't know what T is. So that is a bit of a problem. We're going to have to pass in which turtle we're going to draw with as an additional parameter. So I'm going to put it as the first parameter. So when we do draw star, well, in fact, let's see what we're supposed to draw. It's supposed to be a triangle with bob. So draw polygon. No, draw do polygon is what we've got. And we need to specify which turtle. So that's bob. However, what have we got here? We need sides and size. What does it say? So a triangle has 3 sides, and the size is 100. So we're almost there, except that it's still talking about t here. We need to refactor that to change that so it talks about whichever turtle we pass in as an argument. There we go. Although, wouldn't it be nice if we could specify the x and the y coordinate? So why don't we just do those as parameters, px and py. So all we have to do is, not t, pturtle.goto, px and py, pturtle.penup, so we're not drawing when we teleport, and pturtle.pen down. Will that work? Well, not yet, because we haven't passed in the number of arguments that we need. It's missing 2 required positional arguments, as in we're only passing 3, but it's expecting 5. Let's pass in those arguments now. Minus 100, 100. I think Bob is now going to draw the triangle in the right place. However, Alice isn't yet going to do anything because we haven't told her to do anything. So let's see. Can we draw a star with Alice? Can we specify how big the star is going to be? Can we specify the coordinates? Well, we can specify them, but it will fail because we've passed too many arguments this time. Our definition of draw star isn't expecting these additional 2 arguments yet. But you can change it. You can put those in. I'll leave you to try and work on that yourself. So when you've had a go at this, you need to save your Word document first, close your Word document, and then upload it, please, to Half Term 6, Algorithms and Programming 6. Please check you've put the right Word documents in the right place. There's some of you who are still putting the wrong Word documents in the wrong place, which means you're not getting the marks and you're not getting the feedback for them. Please check when you're uploading, please.